Welcome to this lecture. In this video, I will discuss Laplace transform of single-sided real exponential function. So graphically, it is shown in this picture. So this is exponentially decaying function. It is represented as e power minus at u of t. That indicates the signal exists from 0 to infinity. The function of this signal, we can write it as x of t equals to e power minus at u of t. Now we'll try to find Laplace transform of this x of t. Laplace transform of x of t equals to integral over 0 to infinity x of t e power minus st dt. Now we substitute x of t signal in this integral function 0 to infinity x of t is e power minus at u of t e power minus st dt. Integral of e power minus at u of t and e power minus st is there in this function over the limits 0 to infinity. So u of t is unit step function. So u of t value is 1. So when t greater than or equal to 0 and its value is 0. So when t is less than 0. So in this case the limits are 0 to infinity and u of t value is 1. The integral function becomes 0 to infinity e power minus at and e power minus st dt. We further simplify this as integral 0 to infinity e power minus of s plus a into t dt. So that equals to, this is in the form of e power minus a t. So integral of e power minus at dt formula is e power minus at by minus a. So that we can write here e power minus of s plus a into t divided by minus of s plus a over the limits 0 to infinity. Now we apply the limits, upper limit as first e power minus infinity and lower limit is e power 0 divided by minus of s plus a. So that gives us e power minus infinity value is 0 and e power 0 value is 1. So 0 minus 1 divided by minus of s plus a. That gives us 1 by s plus a. So this is Laplace transform of x of t, so which is e power minus at into u of t. So or we can write it as, so e power minus at u of t Laplace transform is 1 by s plus a. Now we write ROC also, ROC of this function. So we can find from the integral function 0 to infinity e power minus of s plus a into t dt. So this function or this integration is finite for the value of s plus a greater than 0. So which gives us s is greater than minus a. So ROC of this is s greater than minus a. The ROC plot, so we can see now. So this is real axis, this is imaginary axis. Now ROC is exist s greater than minus a. So s it means that the real part of s, which is sigma greater than minus a. So minus a we can mark in the s plane in the negative axis side. So this is minus a, and to draw the ROC greater than minus a, so we use one dotted line here, and greater than minus a, the ROC is exist for this function, so that we represent this area by the horizontal lines shown in figure. So this is the ROC of given function e power minus at u of t. Similarly, if the function x of t equals to e power at u of t, then we simplify it as Laplace transform of x of t equals to integral over 0 to infinity e power at u of t e power minus st dt. This is Laplace transform formula for the given function x of t. Further we simplify it as, so over the limits 0 to infinity, then this function becomes integral over 0 to infinity e power at into e power minus st dt. So now this function we further simplify as e power minus of s minus a into t dt. So this is in the form of integral e power minus a t. So we can write integral of e power minus a t dt equals to e power minus a t by minus a. This becomes minus e power minus of s minus a divided by minus of s minus a over the limits 0 to infinity. Now we apply the limits to this function. This becomes e power minus infinity minus e power 0 lower limit divided by minus of s minus a. So that gives us e power minus infinity is 0 minus e power 0 is 1 divided by minus of s minus a. So we further simplify and write 1 by s minus a. So this is Laplace transform of the function e power at u of t. Therefore, e power at u of t Laplace transform pair is 1 by s minus e. Now the ROC of this function we can find from the integral 0 to infinity e power minus of s minus a into t dt term. This function is finite for the values of s, for the values of s minus a greater than 0. So e power minus of s minus a is there. If s minus a is greater than 0, then this exponential remains decaying function, and which is converges as t tends to infinity. S minus a greater than 0, so that is s greater than a. S is real part of s, which is greater than a, or we can say it is sigma, so whose value is greater than a. So ROC is exist for sigma value greater than a. Now we plot the ROC for the function e power at u of t. So this is real axis and this is omega axis, and for s value greater than a. So we mark the a, the positive value, so which is lies on positive time axis a, and this is origin, and we draw a vertical line at a, and all greater values of a will have the ROC, region of convergence, for this function. So this is indicated by horizontal lines as shown in the figure. So this is ROC for the given function, so which is s greater than a, or the real part of s sigma greater than a. So this is about single-sided real exponential signal, which is e power minus at and e power at signals.